Today, Brazil is the world leader in oil and natural gas exploration in deep and ultra-deep waters. All because of extensive research, development and training programs, and heavy investments in exploration technology. Petrobras has been breaking world records for oil exploration and production in deep and ultra-deep water. Oil and gas in Brazil can be found along the coast at depths of up to 3,000 meters. And the newly discovered reservoirs that lie below the salt layer, in what's called the pre-salt layer, make exploration and production much more difficult and require the development of new technologies. Petrobras has been breaking world records in these situations through accomplishing oil extraction using various types of moored floating production units. Most of these systems are FPSOs and semi-submersibles. In the pre-salt layers of Santos Basin, the greater distances require units equipped with storage facilities, such as FPSOs, MPSOs, and FLNGs, that allow the storage of large amounts of liquefied gas. These platforms are moored by special lines and use anchors, such as the torpedo-type anchor, with taut leg moorings to resist higher vertical forces. The risers are pipelines that raise the extracted oil and gas to the production platform. They should be developed to reach greater depths and withstand lower temperatures, and sometimes make use of cryogenic hoses when working with liquefied gas on the surface of the sea. During the basic design phase, and before constructing the floating units, verification and validation tests are performed with scale models in physical test tanks. For deep water tanks, there are physical limitations to the conventional tests, especially for transversal dimensions and water depth, which do not permit faithful reproduction with the necessary precision needed for the dynamics of the whole system. Representing these conditions properly requires a very large tank, or such a small model that the representation of the physical phenomena and analysis of the scaled platform will not be satisfactory. To innovate and revolutionize the research and testing of floating units in deep water, the innovative Numerical Offshore Tank project was implemented. The Numerical Offshore Tank, or TPN, is a hydrodynamic laboratory developed for the design and analysis of platforms, ships, barges, and other floating structures, involving the joint efforts of a multidisciplinary team of experts and close partnership between different universities, research institutes, and Petrobras. The Numerical Offshore Tank was inaugurated in February 2002 and is located in the Department of Naval Architecture and Oceanic Engineering at the Escola Politécnica at the University of São Paulo, USP. It is also a pioneer in the field of high-performance parallel computing research. The project is a collaboration between the Brazilian oil industry, Petrobras, and major research institutions around the country. With almost 10 years of experience, TPN is a center of excellence in marine and oceanic simulation, and several analysis projects have been conducted that have resulted in strong advances in the exploration and production of oil in Brazil. To increase development capacity and integrate with the computational mechanics tools from other institutions, MC, CENPES, and Petrobras implemented the Galileo network in 2006. This is a scientific computing and visualization network that integrates various Brazilian institutions, including the Numerical Offshore Tank at USP. Galileo is a specialized scientific computing and visualization through virtual reality network for the oil and gas industry. This network is an international pioneering project set up to develop technologies to address the major challenges related to the oil, gas, and energy industries. This network joins together all the experience from institutions with expertise in this activity and will help to develop technologies for pre-salt layer exploration and provide engineering solutions from the oil and gas reservoir to transportation of the processed products. This network is composed of multidisciplinary units and laboratories at several universities and research centers, as well as in the industry. These units act as a grid in this network and work together on various oil, gas, and energy development projects, such as developing the scientific computational tools and allowing real-time, high-resolution 3D scientific visualization of results at each unit. The new infrastructure was provided to the main participating institutions of the Galileo network, belonging to the scientific community. The Catholic University of Rio de Janeiro participated in this network through the TechGraph Laboratory, which is developing oil reservoir modeling, interfaces, and network managing programming codes. COPI from the Federal University of Rio de Janeiro joins the network through LANCE and is developing the modeling of riser structure, platforms, and oil exudation processes. The Federal University of Alagoas participates through LCCV and is developing the structural modeling and oil wells. And finally, USP, the University of São Paulo, participates through the Numerical Offshore Tank Laboratory at Escola Politécnica, which has developed a hydrodynamic calibrator or physical tank, a clusters grid, and a visualization room that allows the results of the analysis of production systems, as well as drilling and reservoir analysis, to be visualized. Other institutions have been added to the network recently, including Unicamp, ITA, LNCC, INPE, Federal University of Pernambuco, Ceará, Manaus, Maranhão, Rio Grande do Norte, and the Federal University of Rio Grande do Sul. The TPN Dynamic Simulator is unique and innovative in the world. It can provide a complete modeling of the hydrodynamic behavior and structure of the offshore system that helps in the development of floating units and predicting tensions in mooring lines, risers, and other offshore production systems. To join the Galileo network and to attend the increasing demands for research and development quality, TPN has developed a new building offering new features for the Galileo network. The infrastructure of this building includes a new high-performance computing cluster with 55 teraflops, performs numerical simulations. It's integrated with the Galileo computing grid, which contains a large number of parallel processing units for generating high-speed analysis and data storage. A 4D visualization room contains the most sophisticated and high-technology virtual reality equipment available in the world today. This room can be used to carry out studies, discussions, and presentations of research results conducted through high-speed internet connection with the Galileo network institutions. This 4D room is provided with a high-definition 3D projection system and a mobile platform, which allows the user to be more deeply immersed in the simulation, analysis, or presentation. The new building also features an innovative physical test tank that includes new technologies for scaled model tests analysis and is able to generate and actively absorb multi-directional wave. This tank is 14 meters wide by 14 meters long and 4 meters deep and belongs to the Archimedes network, which includes the IPT and Lab Oceano tanks. The tank will also be used to gather hydrodynamic coefficients for simulation analysis, which will bring results as close to real phenomena as possible, as well as simulating conventional oil and gas exploration and production systems. The Galileo system is designed to analyze the exploration and extraction of oil and gas from the pre-salt layer. The Galileo system can be used for analysis of floating units in deep water, but can also be used for the salt layer drilling processes, well construction, and multi-phase flows in pre-salt reservoirs. The TPN also offers a multidisciplinary physical space where professors, researchers, and students of various specialties can work collaboratively. The space also contains all the essential infrastructure for receiving researchers, designers, and partners for where they need to work together. The TPN belongs to the Galileo and Archimedes networks and offers a pioneering partnership, providing excellent results for the development of research in oil, gas, and energy exploration and production in Brazil, in order to develop new technologies for pre-salt layer oil and gas exploration. The Scientific Method Management Division from CENPES was the general coordinator of the network and was essential in making possible the integration of the various universities and research participants, as well as cooperating closely at all stages of the development. Galileo is an innovative and integrated system that provides high technologies for oil and gas exploration, which has been established as one of the key areas for development in the country. Along with Petrobras and major Brazilian research institutes, Galileo will contribute to Brazil's oil exploration and production development, especially in the pre-salt layer that occurs progressively in deeper water.